we present this commonly used distribution. So the representation of random variables, we put it as a probability distributions. Right. So if we can recall what we have looked last week, so what random variables consist of discrete and continuous random variables. So the discrete random variables is a probability of mass functions, and the continuous random variables is a probability of density functions. So at the end of last sessions, we have seen that the discrete random variables can be represented by this type of probability distributions. It can be binomial, geometric, or negative binomial, hypergeometric, and quotients. Right. Okay, so let's look at binomial probability distributions. So before that, let us introduce what is Bernoulli trials, right? So the characteristic of binomial distributions. So Bernoulli distribution is the distributions of the number of success on a single Bernoulli trials. So Bernoulli trials we can get on either success or failure, right? So each independent trials can only have two possible outcomes. So it can be success or it can be failure. And if you like, uh, it can be either 1 or 0, right? For example, we can use Bernoulli distributions to answer question like, if a single coin is tossed once, what is the probability it comes up head? So it can be either success, which is head, or failure, which is not head or tail, right? So that is Bernoulli trials. Right. So under Bernoulli trials, right, on your screen now is the example of binomial distributions. However, before that, right, we can have But we can put it we can have something like so if we have independent uh, one is thoughts 20 times. What is the probability it comes up exactly 40 times? So the binomial distributions is the distribution of the number of success in independent Bernoulli trials, right? So right, let's look at example of geometric distributions, right? So if a coin is repeatedly tossed, what is the probability the first time it appears occurs on the eighth toss? right? So the geometric distribution is the distribution of the number of trials needed to get the first success. Remember, the binomial is the distribution of the number of success. The geometric distribution is the number of trials needed to get the first success. We'll recap that later. Right. Now let's look at an example of negative binomial distribution. So the negative binomial distribution is the distribution of the number of trials needed to get certain number of success in repeated independent binary trials. Right. So binomial is number of success. Geometric is number of trials to get the first success. And the negative binomial distribution is the number of trial needed to get a certain number of success. So, for example, it's negative binomial if a coin is repeatedly tossed. Okay. The number of trials. Right. So this number of trials and this number of success is a random variable. Can you see the difference?
Yes, doctor.
Good, good. So we have two more, which is upper geometrics. Right. The hypergeometric distribution is almost similar to the binomial distribution. So we are interested in the number of success in the trials, but it's different because the trials are not independent. It means like uh, each for binomial, each trial is based on the same set of the same samples. But for hypergeometrics, the trial uh, the, there is no replacement from the source. For example, if you already the sample is already a success, so it is not come back to the source, right? So example, if 5 cards are drawn without replacement, what is the probability 3 hearts are drawn? Yeah. For example, if you have let's say 100 cards, yeah, 100 cards. So if you take 5, so the first one is one from 100, right? So the second one is one from 99. The third one is one from 98, because the drawn cards is not replaced back from the source, right? So what if the card is being replaced? What type of distribution is that? Nadia, are you there? Nadia Akilah. Shalisha, are you here?
Yes, Doctor.
Right. So for hypergeometrics, the 5 cards are drawn without replacement. If you replace back the card, what type of distribution is that?
Um, Wait a moment, I think. Hmm, Maybe negative binomial.
Yes, it's binomial. Like we said before, the hypergeometric is almost the same as binomial. So that is the difference. The source is going to be replaced or not. Right? Okay. Good, Alisa. Right. So the last one is gonna be uh, portions distribution. So the example, What is the probability there will be 4 car accidents on a campus in a given week? Right? So there is a relationship between the Poisson distribution and binomial distributions. Uh, the Poisson distribution it approximates the binomial distribution. Right? For example, if the number of trial in the binomial is large and the probability success is very small, so suppose we have a very large sample.
Sorry, doctor.
Yes.
We cannot see your screen now.
Still the same.
Okay. Okay. Now I can see it.
All right.
Thank you, doctor.
So in Poisson distributions, the probability of the success is very small, right? So the Poisson's distribution will answer the number of events in a given time of length or error. So as in the examples, the number of event is the car accidents in a given time. So in a week, how many events occur, right? So there are two parts in portions. So we will later go each one in detail, right? So for now, we can almost get the ideas what is the binomial, geometrics, negative binomials, hypergeometrics, and Poissons. Right, so let's go back to right. So if we can still remember that the binomial distributions look at the number of success, right? So the number of trial is fixed. So the number of success is random variable. So in this case, we are looking at the number of hits obtained uh, when we toss coins 10 times. So the number of trial is fixed and the number of success is random variable. So again, the same for all these examples, right? Right. So I want to highlight N. is the outcomes of independent trials. Right? Let's go back to that later. Oh, that is the mean and one moment. So let's look at the example one for binomial distributions, right? So a six-sided die is rolled 12 times. What is the probability of getting four 5 times, right? So the number of trial is fixed. So n is the number of trials. So capital P of x here is the probability that there will be exactly x success in n trials, and lowercase p is the probability of getting successful event, and lowercase q is the probability the event is failed. So this is the formula, right? P of x equals to nx p power of x q is n minus x, right? So you want the trial number of trial is 12, so n equals to 12. How many times, yeah, successful event? So lowercase p successful event, which is we want to success 5 times, so x equals to 5. So in each trial, how many successful events? So in each trial, only one, because six-sided. So 1 out of 6 is the probability of successive event, and Q is the probability of failed event. So it's 5/6, right? So that is the formula. If you put all the numbers, substitute, yeah, number of trials, 5 successful trial, right? Can you understand? Okay, first we have this. This is the formula, right? So you have all these parameter, right? And then you calculate this first here, right? This is how you calculate it, right? So you have this. So this is how you calculate, right? And then you have this answer. You put back into the equations, right? And then you get this answer, and you get the percentage of the answer, right?
Doktor, kenapa P tu 1/6?
Uh,
Ah,
this success because apa tu die kan, a die have six side, so number of successful event, so you want to get 4, so what is the probability you get 4 when you roll a die? Only 1/6, right? Only one time.
oh,
Okay, understand?
okay.
Okay, so do you want to try with this example? Right, I'll give you 10 minutes to do that.
Yeah.
Anybody got the answer? In percent?
Six
16.86.
All right. Yeah, correct. Everybody got that?
Yes.
Yes.
Okay, that's good. So that is how we get the answers, right? So you have all these informations, and you try to find NCX. So this is NCX 26, and you get this answer. You put back into the equation, and then you get the answers, right? Right. Now let's look at the geometric probability distributions. Let's run. So I think I just go quickly on this. So I just share. Right. So what is the probability of getting the first 6 on fourth roll using a six-sided slide? Right. So if we are going to do 4 trials, right? So 4 trials, 1, 2, 3, 4. So we gonna get 6 on after at fourth trial, right? So of course, only the fourth time is a success. You get fail, fail, fail. So the fail is the probability of fail is 5/6, right? The probability again. So fourth time fail, and 3 time fail, and the last one is success. So the success is 1/6. So the probability distribution is something like this, right? So this is the hard way. So you calculate, you get the answer. Right. But you can also do using the formula, right? So this is the formulas, number of failure times number of success. Right. So you get the same answer, right? All right. So in in the test, or you need to understand both the easy way, the difficult way of getting the answer, or this is for you to make sure that you understand the concepts, and also by using the formula, right? So if you want to try to do this one, I think I just let you copy the questions, and we will discuss the answer on the next sessions. Right. So that's it for today. We discuss the answer on the next sessions. When you already copied the questions, then I think you can go. All right. Thank you, everybody, for the attention.
Thank you, Doctor.
You're
Thank you,
welcome.
Doctor. Assalamualaikum.
Waalaikumsalam warahmatullah.
Thank you, Doctor.
Thank you, Doctor.